This is part 3 of the AQA GCSE Chemistry Dual Award course on the topic of atomic structure. In this one, we are going to focus on separating mixtures and looking specifically at distillation. Now, one of the areas that this can come up is the extraction of fresh water from seawater. I'm going to recommend that as you go through this, you have a go at the tasks that are up on screen by pausing the video, and then you can carry on and review how you've done. So here is the first task. I know it is quite small, apologies. And I think it's important to note here that the questions that you're answering are not necessarily things you will need to remember, but this is a great opportunity to do some comprehension work, finding answers within information that's provided. And that can happen within exams as well. So take a look at the questions. We have got, what does ppm stand for? And ppm stands for parts per million. And we have that just here within the statement. So it essentially means that if we're talking about something being 1,000 parts per million, there will be 1,000 molecules within a million molecules in total. What does the word desalination mean? Well, that is removing salt. So if we think about taking salt water and we remove the salt that's in there, then we end up with pure water. We end up with fresh water. So that's what the word means. The first person to suggest distillation as a way of extracting fresh water from seawater was Aristotle, and it was over 2,000 years ago, but a prime example of something that won't come up within the exam. Calculate the ratio of the amount of salt in seawater compared to the amount of salt in fresh water. Well, seawater is 35,000 parts per million. We see that here, whereas fresh water is only 1,000. So it's a 1 to 35 or 35 to 1 ratio, depending on which way around you look at it. In terms of the specific question, seawater to freshwater, it's 35 to 1. And finally, describe how distillation can be used to get fresh water from salt water. You would need to be able to explain this within an exam based on your knowledge of separating mixtures. But distillation is two processes, one after the other, in sequence. First of all, we evaporate, and in this case we're evaporating the water in salt water. The salt gets left behind, but then we're going to condense that water vapour where we're left with the pure water. Okay, this is a chance for you to think about missing words to go in. There's some anagrams to help you. You might not need the anagrams, but you do need to think about the most appropriate keywords. So, salt is a solid which dissolves in water. Salt water is a solution. We can see through salt water. A word to describe this is clear. Solids like salt, which dissolve in water, are soluble. All really important keywords here. Chalk does not dissolve in water. It is insoluble. When you mix chalk with water, the liquid turns cloudy. And when you mix sugar with water, the sugar is the solute and the water is the solvent. And I'm going to add a little bit here, just as something that might help you to remember some of these key words. The solute dissolves in the solvent. So the solute is the solid that dissolves. The solvent is what it dissolves into. For this task, you're obviously not going to do the practical. And there are some questions on here that I will talk about, but it's the diagrams that I want to focus on. You've possibly done this much lower down in school, where you have rock salt, which is sand and salt together. And the process that you go through is that you will first put it into water. The salt will dissolve, the sand won't. You can then filter that and the sand remains in the filter paper. And then you can evaporate the salt water and you can collect the salt. Now, if I go through the questions, I've not written the answers down here, but how you obtained, I've just gone through the process. We filter and then we evaporate. I'll talk about the diagrams in a second. Crushing the rock in step 1 increases surface area. That means that it will dissolve more effectively. And we talk about that in the rates of reaction topic later in the course. When the water was added, the salt dissolved. when we filtered, the sand stayed in the filter paper. The salt didn't stay in the filter paper because it passed through the filter paper because it was dissolved in water. Now, the diagrams is what I want to really focus on here, as I've said, and they should always be two-dimensional and cross-sectional. They don't have to be perfect, and my drawings are testament to that. They're not perfect straight lines. It's good to use a ruler. It's quite difficult to do on screen. But the most important thing that I haven't done here is label them. So I've now added the labels on, and you should label every part. Bear in mind, you don't need to draw a Bunsen burner. You can write heat with an arrow pointing upwards. So that takes us to the end of this video. Thank you for listening, and goodbye.